Hello, this video is about Miro and Frederick's Bang Bang algorithm line follower. The key feature to a successful line follower is a sensing mechanism. Ours was the combo of an LED and a photoresistor. When over black, less light gets emitted back to the sensor, whereas when it's over white, the opposite occurs. Within our circuit, the more light the photoresistor absorbed, the less voltage could go across. And thus, when over black, the Arduino read a higher voltage, and when over white, the Arduino read a lower voltage. As you can see in our code, we made a function to read the analog voltage input from the photoresistor's pin using analog read. In Arduino's analog read, it paints the input of 0 to 5 volts to an integer between 0 and 1023. Generally, the integer values varied from around 500 to 950 over peak black. So these sense values were used to control the steering of the servos. When the left servo was faster, it turned right, and vice versa. Based on if the read value is greater than or less than our experimentally determined threshold, the Arduino would output the assigned PWM voltage to the servo objects using servo write. Pulse width modulation is the method used to deliver analog voltage using digital means by varying the pulse width and periods of digital pulses. As shown in this straightaway, when it was larger than the threshold and over black, the left servo would be faster, and when it was less than the threshold and over white, the right servo would be faster, and so it would turn left. This creates the zigzag pattern you just saw. One of the differences between turns and straightaways is that on the turns, the servos that are furthest from the curve have to be dominant. By dominant, I mean that it has to run for longer, even if only for a matter of milliseconds. So on this left curve, it can be seen that the right wheel is doing more work than the other one. And on this right curve, the left wheel is doing more work. You can see that the left wheel has to travel further than the right wheel. And when you put all those concepts together, you get a line follower that is able to cleanly follow any arbitrary loop. If the correct logic is there, it should even be able to do any loop in any direction and any starting point. The only difference is that in the counterclockwise direction, it's on the outside of the loop, while on the clockwise direction, it's on the inside of the loop.